Next, we're going to look at the image class. The image class simply represents a graphical image that you use either a file name or a URL. In other words, you can grab something off the internet, off the web, in order to use it as an image. And both such examples are shown for us here. We can say new image and then give a path name and a file name, as we've done here, image us.gif. Or we can specify a URL. We can say image http:// and we can give them a URL and get an image in that way. Either way, we can't actually show the image as it exists this way. There's sort of an analogy between what happened earlier with files and print writers and scanners that we saw earlier. The file object was merely used to specify a particular file name and to do some rudimentary file checking of properties and so on, but you couldn't actually read or write to a file using a file object. Rather, you would pass that file object in as an argument to the constructor of a scanner or of a print writer in order to actually use it. In much the same way, an object of class image in JavaFX is merely a specification for an image, and you can't actually use it or see it as it exists that way. Rather, you need to use something called an image view, which we will look at next. The image view will allow us to actually use an image view in our graphics and therefore be able to see it. The image view will accept as an argument during construction either an image that we've already created based on what you saw on the previous slide, or we can actually go one step back and give a file name or a URL as an argument, a string, and it will effectively go through the motions of creating an image object from that, and then in turn using that as an argument for creating an image view. Both methods are shown here by way of two separate examples, so let's go through them one at a time just for clarity. In the first case, we create an image object of class image by saying new capital image and then giving, in this case, a file name. We then take that image and pass it as an argument to the next line of code where we create a new object called IV of class image view, and we do that by saying IV equals new image view, and then as an argument for the constructor we pass the image object that we've produced in the line above. But as an alternative, we can simply kill two birds with one stone, which is what happens in the alternative implementation that exists at the bottom of the slide. Here in one file swoop, we create an object called IV of class image view, and we set it equal to new image view, but as an argument we give a string representing a file name, and from there it automatically creates the image and then creates an image view out of the image. As usual, there's a UML diagram here mostly for your reference, but once again, a few things that I'd like to point out about this diagram and the next one. First of all, you'll notice that there is a progress method. And the purpose of that progress method is because sometimes you're not going to be loading an image from disk, but it's coming as from a URL from out on the internet on the web, and because of that it might take a while to load, and it might not load at all if there's a problem. So it's useful to be able to monitor the progress of your load, and at some point you may decide to abort if it's taking too long, and this will give you the facility to be able to do that and make those kinds of decisions. Whereas the previous UML diagram was for the image class, this is for the image view class now. In the following three slides, we're going to work our way through a demonstration of using image views and images. We're also going to see a new kind of pane used that we haven't encountered before called the H-box. So let's start about the fifth line down in the code here where we create an object called pane of class pane, and we set it equal to new H-box 10. The argument 10 in the context of the constructor for an H-box here would indicate that we want a spacing of 10 pixels between items that go into the H-box. The H-box is one of many different kinds of panes that we'll be learning about, so we'll talk more about it later. But all we need to know for now is that there will be a spacing of 10 between items that are inserted into this box, and this pane will have items inserted that will appear from left to right. The first one will appear on the far left, and as we put subsequent items into the H-box, they will appear to the right of the previous one that we put. We also see the use of the set padding method with a pane in the context of this particular program, and you'll notice that the argument for the set padding method is something called insets, which represents an amount of padding expressed in pixels, top, bottom, left, and right around the image. The first argument of 5 represents the number of pixels of padding above the image. The next 5 represents the padding to the right of the image. The third 5 is the padding under the image, and the fourth and last 5 that you see there would be the padding on the left side. Now, I said image each time, but really it's whatever node we put into the HBox will have that padding around it. In this particular case, we are indeed going to be putting images in, but in the event that the node was something else, it would still have that same padding around it. Now, moving to the middle of the slide, we see the code that's responsible for creating an image and an image view. To create the image object, we declare it to be of class image. We set it equal to new image, and we use the constructor with a string argument, which indicates that that is either a file name or a URL. In this case, it's a file name. So there would be a subfolder called image, and inside of there would be some pictures, including us.gif. That's a designation for a particular kind of graphics format, and this is actually an image of the US flag. Note that our image object is not anonymous. We've given it a name. We've called it lowercase image. That is in contrast to what happens in the next line of code, where we do not name the image view that we create, but we rather create an anonymous image view. So we do that in the context of adding it as a child to our pane. And remember how this works. We have pane.getChildren, which produces an observable list object now, and then we use the .add method to that to add a child to it, because at this point it would be empty, and the first child we add to it then is an anonymous image view made from the image that we just made in the line above. Moving on now to the bottom section of code, we create another image, this time called ImageView 2, and it's still going to be created from the same picture of the US flag that we did before. But we're going to use the set fit height and set fit width properties to force that image into a 100 pixel by 100 pixel image, which is not what it originally was sized to be. So it understandably is going to be somewhat distorted now. It's going to be perfectly square, whereas the actual image of the flag was not square to begin with. That's going to cause some distortion, but that's okay. We're going to see how that looks in the final output on the next slide momentarily. As we did above, we added as a second child to our pane, and remember our pane in this case is an HBox pane. So what will happen is when we add that second child, it will appear to the right hand side of the first child in a single row, because that's what the HBox pane does. Continuing on with the code, then what we do next is create yet a third image view of the same flag. So we say ImageView 3 equals new image view, and we put the same image yet again in here. Next, we use the setRotate command with an argument of positive 90 degrees to rotate the entire image 90 degrees clockwise. After doing so, we add that as our third and last child to our HBox pane. Our HBox pane now contains all three different variations of the same image, and we now, in the bottom block of code you see here, create a scene into which we drop our pane immediately. We then put a title on the stage. We drop the scene into the stage in the second last line of code, and finally in the last final line of code we show the stage. The resulting window is what you see up at the top of this slide. So you can see the first image view in the left hand side is the flag in its normal form. In the middle now, in the HBox, remember the HBox is going to display everything on a single row, left to right in reading order, and so the second image now appears to the right of the first image, and that's the square flag that we forced into a 100 pixel by 100 pixel area. And finally, the last flag is going to be the one on the far right, and notice it's the one that's been rotated 90 degrees clockwise.